Okay, this is a third and possibly a final review question, and I just made it up, so it's not on your review sheet, but it has some of the other components that you're supposed to be able to work. So let's look at this problem, let's work through it slow and easy, and see if we can't come up with some answers. Let's start out with purple. So, you should recognize this thing over here on the left. This is a thing where we're applying a force to a spring and it has a K value. So right away, you have F equals Kx, and you have the potential energy in the spring equal to 1/2 Kx squared. So we're going to be using those two equations. So let's substitute in. We got 240 here and we have 60 here, and we're solving for x. So 60 divided by 240 is 0.25. So that's 0.25 meters right there. And we're going to substitute it into this. So 0.25 squared times half of K, which is 120, equals 7.5 joules of energy. Now, that's the potential energy stored in the spring, but when we let go of the spring, it's going to cause that block to slide to the right. And right here, when it gets to the edge of the hill, it's got 7.5 joules of kinetic energy. But it's 1.5 meters off the ground, so it also has potential energy. And we're interested in the total energy of the block before it goes off the hill. So the potential energy, we'll put that up here, the potential energy is equal to mgh, and the mass is 1, the g is 10, and the height is 1.5. So 10 times 1.5 is 15. So if we add the potential energy of 15 in there, we've got 15 plus 7.5, and that's going to be 22.5. So the total energy right here is 22.5 joules. Now, when it goes to the bottom of the hill, the kinetic energy is going to be equal to 22.5 joules. So the amount of energy that we have right here is going to be equal to the energy that we had at the top of the hill, which is just like the conservation of energy we already talked about. Now, we need to figure out the work done across this section. Now, let me give this a distance. Let's say that this is 3 meters. We'll have to calculate because I'm not sure what we're going to get here. Coefficient of friction times the normal force times the distance. So we've got 0.25 for the coefficient of friction. It's a 1 kilogram weight, so that means the normal force is 10, and then the distance is 3. So 0.25 times 10 is 2.5, times 3 is going to give us a work done. The work done is going to be 7.5 joules. So it's going to take away 7.5 joules of that 22. So 22.5 minus 7.5 takes us back to 15 joules of kinetic energy right here after.